Our next speakers are Meghan Hoyer and Larry Fenn. And the thing is, right, a lot of us in academia, we're thrilled. We've got 70 participants here. We've got 23 people on the YouTube. We're thrilled if we get 100 people reading our papers. I mean, that's a great outcome. And the thing about data science in journalism is that, and correct me if I'm wrong, I would imagine you're sort of aiming a few magnitudes larger than 100 readers. I'm not an expert, but that's my guess. And so it becomes very important to get things right. My understanding also is that in contrast to academia, where we perhaps have months or years sometimes to do our research, you perhaps have hours or days, and increasingly as there's larger and larger investments into data journalism, there's competition, of course, for these works as well. And so reproducible research becomes very important. Our presenters today are Meghan Hoyer from Washington Post and Larry Fenn from Associated Press. And they're going to talk through some platforms that they've put together to make all of this work. So thank you very much for joining us. I really appreciate your time, Meghan and Larry.
Thank you for a great introduction. Hi, I'm Meghan Hoyer. I am currently the data director at the Washington Post. That is a very new role for me. Previously, I was the data editor at the Associated Press, so I worked very closely with Larry for about 5 years. And just to give you an idea, I mean, data journalism has been around for quite a long time. I know that there's a lot of talk about it being relatively new because election forecasting and election predicting have become much more of a sport in the last couple of elections, but data journalism goes back a lot longer than that. And as Rowan said, like there's a lot of what we're doing is we're working on deadline. We're doing pretty sophisticated analyses over long periods of time as well. So we have to be both fast, we have to be able to move nimbly with the news, and then we have to be able to take a step back, do long-term projects, but our long-term projects are probably a little different than most people's, and the fact that we'll plug a file and to it a month later when we have time because we've been interrupted by things like COVID or flooding somewhere or a natural disaster. So there's a lot of our work has to be reproducible, has to be well documented, because we have this, ebb and flow of a couple of projects you see from NFL teams in looking at injuries to flood insurance policies, and that was very much off the news in looking at how the US was handling flood insurance and how places were set up to handle space storm. Obviously, COVID kind of sent us into overdrive, so we did a lot around inequalities around, nowadays it's vaccine, COVID, we were at the differences in how this was affecting people in different races and in different areas of the country. We collected data. We hand collected data from 800 school districts to look at the differences in how people were going back to school and how kids were going back to school. And measuring segregation systems. So this is a project, the middle screenshot is a project that Larry worked on for probably 8 months to a year, coming up with different ways for segregation. So our work is both very fast and long-term, but work also really has to be accurate. I mean, in a project, all of these projects ran in more than 100 different news sources, and every the word is like it's about like 1/3 of the world's population consumes some amount of AP content or some bit of AP content. So there's this tremendous pressure to make sure that things are accurate. As such, we have to have the backstops to our work, and those backstops have to be fast and nimble as well. we have the ability to check everybody's, to make sure that this is and done well, that it's moving forward in the right ways, that we've measured things correctly, that we haven't missed problems with the data, we haven't overlooked things. So we really have to work as a team, and that creates some challenges that don't necessarily exist when you're working as a solo data analyst. So what we found were, we were seeing, as we assessed our workflows a couple of years ago when we were starting out as like a larger data analysis team, there's obviously the problems you see. People have different programming languages. Do they use version control? How do you use version control? What kind of version control are you using with your code? Are you on GitHub or GitLab? Things like that. Where are you putting your data files? Are they living on your computer? Are they up in the cloud somewhere? And how is someone who's going to check your work have access to that data storage and those raw data files? And then how does someone have access to the data files and the outputs that you're creating when you're doing a project was also a challenge. Obviously, file paths and directories are always a challenge when you're sharing work among people on the team. How can people recreate your work when the directories aren't set up, or it's hard to, there's not relative file paths, and file paths are hard coded. How do you remake that? Having consensus on project structure was really important to us. Everyone kind of codes and works a little differently. And what we were finding was it was hard to figure out when you were dropped into a new project and you either had to help someone, or you're building on top of an analysis they already did, or if you had to check their work. What order do you run files in? How do you know that you've hit all of the markers? How, if you stumble upon a file of like kind of archived code, or code that they ended up not using in their final analysis, how are those things identified, and how do you see their output? And really important when you're working on a larger team. And then finally, like the thing we were finding is like the team practices and how we worked was like codified in a variety of like different docs, but it wasn't automated, and it wasn't something that necessarily was adhered to in every single project we were doing. So we would say, yeah, we're checking everybody's work, this is how we're going forward, but because those systems weren't automated and were very much person to person and kind of passed down through lore, it wasn't necessarily something that happened the same way on every project. So we took all these problems, and then we kind of started scoping out a tool that would help us kind of stay on those rails a little bit better, like that would automate a lot of our team tools and templates and things like that, that it would create shortcuts for common tasks. Like, if we're creating our Markdown document that we're going to share for our findings, what kind of templates are we using for that? Can we make sure that each our Markdown report has the same system for timestamping when the analysis happened or when something was updated? Can we create themes around what our graphs look like and what some of our outputs look like, so they look like something coming from the AP and are thus easier for the reporters and editors we're working with to understand. And finally, we just wanted to kind of create a shared and common project structure so that we could easily collaborate amongst ourselves. What we found worked the best for us was creating talking together, sitting down together, figuring out what our project structure, what we wanted each project to look like. And then every time we were making a project, have that structure be the same across every project. So that, if I dip into Larry's work and if I need to add something to it, or if I want to build off of it or double check it before it runs on the wire, that there's an easy way to do that because I understand what his project structure looks like because it looks exactly like mine. So, we took all of these things into consideration, and we developed, it was really a team effort. We developed a tool that we've called DataKit. which is open sourced and accessible online, to just kind of create that project structure, and then also to easily sync up to to GitHub or GitLab, to S3, and basically create, like, automate a lot of the processes and make it really easy to work together. So Larry's going to walk you through kind of the basics of DataKit and then show you a little bit how it works.
Thanks, Megan. Hello, just double checking. Okay, yes. So yeah, as Megan said, so we developed this tool called DataKit, and really it's architected in such a way that the commands are themselves these like little plugins, but the really essential ones are the ones on the slide here. So there's project, which will sort of create the folder structure. It sets up the basic scaffold, you can imagine, of the whole project structure. Before DataKit, we had this problem Megan alluded to where some people would be grouping data files one way, some people put them another way, some people liked to put ETL scripts in a different spot from their analysis. And so this is just a way for everyone to agree and say, okay, let's just decide on an organization and just encode that into a single command for a folder structure. DataKit data, like Megan said, is basically, we use S3. We decide our data sets sometimes are way too large to put into version control. So we decided instead to have this little shim here that it simplifies the sort of process of syncing with S3. There are these subcommands within it that, if you want to pull, if you want to push, that's how you can do that. And then lastly, we built these two to control, again, very basic, but very easy to automate, very standardized sort of how do we want to sync code up with remotes, and for both GitLab and GitHub creating issues from the command line, because that was another thing where, it was like sort of low-hanging fruit to automate, where, there's a little bit of friction to go through the web interface, but really it's fundamentally the same idea. You just want to create a project issue to track something that's on your to-do list. In addition to these that we sort of started life with, there's also been some community contributions. We've been fortunate enough that after we open sourced this tool, there was enough interest initially, at least, to some people decided to take the architecture and run with it. And so they've actually created their own extensions. And that's really the underlying principle here is, as we develop ourselves as a team, maybe we end up using new tools. Maybe we embrace Docker in the future. I can't say. But the idea is, the overarching tool, we would just develop another plugin to sort of, once again, configuring a Docker container every time is a little fiddly, it's a little error prone, and it requires some sort of, know-how for Docker that's really not necessary for more, for stuff that's more focused on data analysis. If we end up embracing it fully, we can just automate all of that in a single command, because we only really have one, very concrete use case defined. We don't need a general purpose sort of Docker interface. So here we have Bitbucket and G Drive for people who use a different sort of version control, a different sort of cloud sync data model. And I think it's great. I think it's sort of a test of the strength of the DataKit architecture. So I'm going to go now to a short demo of what it looks like, actually, because we've been talking so much about it. It'd be nice to actually show it off. So let me first zoom in. Is that a thing I can do here? Is that a thing that, I know this is, yeah, there we go. Let me zoom in on this, because I know on screen share it can be kind of, oh God, I've zoomed in too far. Okay, so the basic, I believe this should work, yes. I'll see it in the live demo. Oh yes, okay, so the basic command is DataKit project. And so yeah, each command you invoke, there's these subcommands based on your plugins. You can see I have a variety of plugins installed. And so let's just say, or let me switch into this directory. And so let's just say we want to make a new project. So right now there's nothing here. And so we actually support a config that fills these out by default, but just for the point of the demo, I'll show how you just sort of type these out. And so the project slug is important because oftentimes we interact with broader AP systems, and it's useful to have a sort of, the slug is sort of the handle for the project that's distinct from the title, demo project. Okay. And so right away, you can see what this has done is it creates the whole folder structure. It even creates a sort of very rudimentary templated README file for our purposes. Actually, I think I have it prepared this already. Yeah, and I'm using the R project template. We actually have a Python and a more generic project template, but just because my workflow is always in R, I've tailored it to that way. So someone who's on, one of my colleagues who uses Python primarily, their overall folder structure will look the exact same. They just won't have these two files in there, the R specific ones. But crucially, the data is in the same place. The analysis code is in the same place. All the other stuff that would be there is in the same place. So let's pretend I'm working in this project. I've made this new project. It's all configured the way I want it to. And let's just pretend we, I'm gonna just mock up writing a data file here. I think that should work, right? Or you know what, I'm gonna do it normally the way I'm used to, the tidyverse. Cars. There. So that's me having done the work here. I've put, let's just pretend that's something that's happened. And now, so right now there's no Git initialization. And so that's another step. So we have this, let's say I want to put it in GitLab. So I just run this command and it'll fire it off to GitLab. It'll do sort of the, it's just an alias really, like it's doing git init, git add, it's doing the git ignores, it's, doing the commit, setting the remote, pushing up, boilerplate stuff, but it's stuff that happens every time you make a new project. So it's just that much faster. And we know it's going to go to the same place every time. So once you set up the sort of configs, there you go. And so now we've got our Git repo. It's on the GitLab. And now let me just show off. So we can also do DataKit data. DataKit data hooks up to S3. And so there's an init that actually first defines a config file. And something. Okay. Anyway, the Git, it just defines a Git config, it defines a config to tell basically which S3 path. And that's where the project slug comes in handy here, because that's actually where the S3 bucket is. And then if I just do DataKit data push, it'll go ahead and fire that off to S3. So you can see here, again, if you know your AWS command line, it's not doing anything very particularly magical. But it's, again, typing this out every time. It's error prone. I remember one of the very first projects I worked on after joining the company, I did a typo, I blew away a directory, an important directory, and that's these things happen. And so automating what are really the same commands every time, we just want to push the entire data folder into a sort of S3 bucket that contains it, lets me do that quite easily. And so, let's pretend now that I'm checking Meghan's work. So I've cloned her project, and because we don't check in our data files, I'll have her code, but I won't have her data files. But because the config is there, because we use the same S3 bucket, this just does the corresponding command. And again, it's not doing anything particularly crazy, but it's just doing the sort of work of retrieving the data from the cloud after I pushed it up there. So that's really the core of it. There are other, so you may have noticed earlier when I did the commands, there's another one here that we didn't talk about. That's to do with the sort of data sharing platform we have, data.world. So it's really not too hard to, I didn't push, whatever. It's really not too hard to add plugins as we see our needs change. And that's really the important thing here. Likewise, for the project templates, we revise those periodically as needs change, as we understand different technologies, or we realize we are doing something really often and we need to automate it sort of more quickly. So with that, I think we're a little early, but we can open it up to questions.
That was amazing. My mind is blown. Congratulations to both of you on fantastic product, and thanks for taking us through it. If anyone has any questions, please feel free to add them into the chat or into the Slack chat or the Zoom chat. Harlan asks, how do you deal with project structures that evolve and get more complicated over time?
We do have some written documentation, and I think that's on one of the open source pages that kind of codifies how we number our analysis projects and things like that. And then what happens if we have like a secondary analysis off of the same initial project. So we've thought through some of that, and it's in the docs a little bit. So, there are different ways to do it. You can also fork a project and just kind of, create a new repository for something that's going to be, hey, I want to do an update of, flood insurance data 2 years later. Some things have changed. Maybe it's easier to fork up the project at that point. So we have a couple of different ways to handle that. The biggest thing, honestly, is organizing inside the project those ETL and analysis files so that you can work either simultaneously with someone else, or you can kind of organize, hey, this is the order of how the code needs to be run. I will say this has helped us out. A couple of years ago, we handled some projects that were huge in size in terms of opioid sales across the US.
Oh, yeah.
And at that point, we had 5 different data journalists who are all working within the same project at the same time. So we are all committing code and all using the same base data to do our analysis, and then all merging. So it does help on things like that when you're also working alongside someone else with the same data.
Yeah, I actually used that opioid data that you put together.
Okay, yes.
It was enormous. So I have some
very
feeling. Big. Yeah. Just briefly, Nick asked, how big is the data journalism team at Washington Post? And I guess we should also ask at AP as well.
At the Post right now, the data team there's basically 8 people who do data analysis. The proper team is 7 people, and then there's a couple of other people who have dotted line connections. And that's simply on the data analysis side. There's also an engineering team, and then there's separately an interactive graphics team that builds out those super fancy interactives that you will see at the Post.
And is AP? Oh, sorry. Yeah, the AP side is, I think, roughly similar. I always forget the exact number, but it's something like that. There's, I think, 4 people who are officially like just data analysts, but then there are quite a lot of dotted line connections. And then there's also, I think, 4 people who do, sort of more engineering news application. There's a separate graphics and interactives.
Yeah, I feel like so many of us are slash these days. We're data slash something or data. Yeah. John asks, how does it handle authentication with Git? As GitHub depreciates password authentication, do you plan to switch to SSH keys or personal access tokens? Does the user set this up, or how does this all work?
Yeah, that's something the user controls. So we are just using. We assume that you have already set up GitHub, like your local configs, to do SSH or personal access tokens. One of the things we've been wanting to build out actually is a sort of DataKit config checker tool, because this has come up before where people on their team, get new laptops, or they need to work from home on a different computer, and then it is a little bit of a pain point at the moment. But we basically everyone on the team basically has to do SSH authentication. This is also because our internal GitLab server only, I believe, or maybe, I think we're only connecting to that through SSH as well.
If anyone has any other questions, please feel free to add them into the chat or the Slack. Can I ask a bit of more of a meta question? You must get a whole bunch of people applying for jobs to work as data journalists and things these days. What do you wish that they knew? What are the skills that we're not teaching them?
my big ones, and yeah, I actually I'm on 2 different hiring committees right now for data journalism jobs within the Post. My big ones are ideas, people having strong ideas around how to use data for journalism, which is slightly different than using data for research, right? How to tell stories with the data. And then the other big one for me is simply a will to collaborate, because our jobs are very, very collaborative. We work really across the newsroom. We have to do a lot of stuff with the engineering team. We have to work closely with okay, sorry about that. We have to work closely with the graphics team and other editors and reporters across the newsroom. So I'm really looking for that level of collaboration. Finally, the last thing is what we see, especially from folks and applicants who are outside of news, is too much reliance on data and having a belief that data is clean and it tells the truth always. So we are looking for a high degree of skepticism around data and ways to overcome that. So, you know, one of the things, Larry was not in journalism when he applied at the AP, and one of the things that so impressed us about him was that he had a very high level of skepticism around data sources and new ways to overcome problems in data sets, because pretty much every data set is problematic.
I would echo, there's a sort of reality of working with like real world data projects. There's a lot of sort of, as far as I know, it's been a while since I've been in a university setting, but there's a lot of sort of unwritten principles of like, yeah, you're generally not going to get something that's both geographically very specific as well as very temporally specific. And just coming to grips with that, accepting it, and moving on quickly, so you know, to something that's actionable is something that I think is really important in journalism, because you always it's all compromises, and I think a lot of times people who haven't had a lot of experience working on data projects, they might suspect, but they don't really feel the constant grind of like, yeah, these data sets are always such an imperfect picture of what.
If anyone has any other questions, feel free to add them into the chat. So Meghan, your background is journalism, right? Whereas Larry, you're more maths. Sorry, I'm Australian, so I say maths. Math,
yeah, that's right. That's right.
For the US. Sorry. Did you have any, Meghan? Did you have any? Did you feel like you weren't a quant person, or like how did you overcome? Some people are intimidated by statistics. Did you have any of those sort of feelings, and how did you overcome those?
Yeah, I mean, I obviously my background is in journalism. I have multiple degrees in writing and journalism. I've always had a math focus, like a math kind of mind, but I don't have the training that folks on my team do. And honestly, I don't need to be the smartest person on my team on that. I bring a pretty high. I joke that everyone on the teams that I work on is generally smarter than me, which is what I look for. And you know, my job is to make them successful in a journalism setting. So my job is to make sure the projects run well, that we're accurate. I tend to have a high degree of skepticism around everything. So I ask a lot of questions, and you know, I can generally, even if I don't understand all the math that's going on that Larry is doing, I understand generally the questions to ask from a just common sense standpoint.
And where's the project going? What's the next steps of the development?
There's kind of a lot. So I mentioned the config tool. There's something we want to kind of overhaul the way that data sync works. It's there's definitely some things we want to try experimentally adding. There's also some stuff around the version control. In particular, we use GitLab, so there's some stuff, you know, we want to spruce up with GitLab. There's something that's a little bit more exciting on the project side. This comes back very concretely to the business needs. We're thinking about ways to encode higher level organizational things into the project command. So what I mean by that is just like calendaring, like, okay, when do we think this can be ready, or when are the last meetings? If we could, something I'm looking into right now is, generating automatically some sort of like ICS file or some sort of calendar metadata that then can be easily grabbed from, something that crawls the code repo, that can sort of quickly and automatically generate a nice little sort of calendar outline of projects that are ongoing, things that are working. I know Meghan would have really appreciated this as a real tool, but maybe we can eventually build it, open source it, and make it available to people.
Yeah, I love that idea. That's so fantastic. Sylvia, did you want to expand on your question, or Meghan, did you want to expand on the answer?
I'm sorry, I'm getting there's a question in the chat about, example of project meetings, and it really depends on what kind of story we're trying to tell and how much time we have to tell it. So off the news things, we tend to move quickly. We might, in cases where we're moving really fast, we tend to pair code. We found that actually works faster. So oftentimes multiple people will be tasked with a project and they will be sent out to go. They have an idea around a data set, and there's we have a day or something, 2 days to turn a story. So, those people might pair code from the beginning and working out a methodology that makes sense, dividing up the tasks and then going to town on that. For larger term projects, it can take a variety of angles. Sometimes a reporter will come to us with a question. Sometimes we have a question that we think a reporter should be looking into, and we'll dive into the data analysis that way. We tend to have 3 stops along the way to back check methodologies, to kind of problem solve in the middle of a data analysis, and then to do a full code review at the end of a project to check our results. So there's multiple places where other people on the team are getting involved and checking our work and kind of checking assumptions, things like that. But projects involve a lot more people in the room than just the data analysis analysts. So there's lots of talk, and Larry's a master at this in terms of the iterative process of presenting results. We present our results in our markdown document. Those are sent to a reporter. The reporter takes a look, might have 3 more, 4 more questions. So Larry will add to that our markdown document, and we may reknit something, 6, 7, 8 times as we're going through, and maybe adding different questions to the analysis, or diving into different parts of the data set to answer questions that a reporter or editor thinks are important. So it's extremely collaborative and also extremely iterative. Larry worked on a project last summer on FAFSA applications, and I'm pretty sure went back and rejiggered parts of that analysis or tried different parts of that analysis 4 or 5 times.
Thanks very much. Maybe just one final question, because we should move on. But Lars asks about the other public data repos that you've mentioned. And I mean, we've talked about the opioids ones, which was amazing. And thanks for making that one. Are there other ones that you wanted to do a sales job on?
We do have some. The AP uses data.world to share its data. Some of those data sets are public. For instance, we have, there's COVID cases. I'm sorry, I'm saying we still, because I'm very close to AP still. But, we followed COVID cases for last year. We made public COVID cases in prisons that we were collecting with the Marshall Project. And that's a hand data collection where we send reporters out to every single state every week to get the number of cases, COVID cases, that are hitting state and federal prisons. That's some of that. We've shared code in the past. We have also, at both the Post and the AP, have shared code in the past. We tend not to do it for every project. At the AP, partly because it is a product for the AP shares its data sets and some of the code and methodologies behind it with a group of other news organizations that then use that data to tell local stories. So that happens about 25 times a year, where the AP will do an analysis, a national analysis, and then share a geographically granular data set with other news members so they can use it for local stories. So because it's a product, the AP tends to do a little less public data sharing. But if you go on data.world, there's probably, a dozen or more public data sets. And those are very heavily documented and go into methodology, things like that. In terms of fully public code repos, I don't know. The Post has a couple, the AP has done a couple, but mostly just to ingest and start handling large data sets. But I don't think we've ever done a full on, here's all the code we use to get to this story. We've looked at it in the past. In part, it just, honestly, it's a little bit of a time suck because preparing public data is, that's another thing. It's another task. How your data sets look publicly versus how they are privately is a different world. And the overhead to that is really too great when you're working on a small team. And yes, we work entirely within the tidyverse, both at the Post and at AP.
Thanks so much for your presentation. It was just a wonderful tool, and it's so exciting to hear the work that you're doing there. So be great to hear more about it at another time. Thanks so much. Really appreciate it. Thanks, Larry. Thanks, Meghan.
Thank you.